Hello and welcome to this session on the top React interview questions and answers by Intellipaat. React, a powerful JavaScript library developed by Jordan Walk, a software engineer at Meta. However, since its invention back in the 2013, programmers always had a mixed reaction to it. Yet, React was elected as the second most used web framework globally for 2024, with over 39% of developers using it. Another article by NASCOM highlights various reasons why you should pursue React.js. Truth be told, React may have its quirky aspects, but with powerful features like the virtual DOM, hooks, the context API, and a whole ecosystem of features, it is a force to be reckoned with. Moreover, the 8,000 plus job opportunities and an average annual salary of 4 lakhs further proves its demand and importance within the tech industry. Now, if you're still with me, then let's get started with this video. As mentioned earlier, we're going to discuss 20 questions in this particular video, which have been put together by our top 1% industry experts who have over 7 years of experience in the web development field. Before we begin, if you want more such content, then make sure to subscribe to our YouTube channel and hit the bell icon to never miss out on an update from us. So without wasting any more time, let's jump right in with our first question on my list. What is React and why is it popular? React is a popular JavaScript library used for building powerful user interfaces. Its key strength lies in its ability to create component-based architecture, which allows developers to create reusable UI components. Additionally, React's virtual DOM is able to create a copy of the real DOM that minimizes direct DOM manipulations, which significantly boosts performance. We'll discuss more about the virtual DOM in the upcoming slides, so make sure to stick till the end. Moving on to our next question. What is a single-page application or SPA? A single-page application is a type of web application that loads a single HTML page and then, instead of reloading the whole page, only updates the affected parts of the page according to the user's actions, like only rendering the color change here from light blue to pink. This means it only contacts the server for the components in which you have added new features or have made certain changes. Now, this process results in faster load times, better responsiveness, and smoother user interactions. However, using SPAs can become a challenge when it comes to search engine optimization because the application uses a single URL, so it becomes harder for the search engines to crawl and index content effectively. Moving on to our next question, what is JSX and how does it differ from HTML? JSX or JavaScript XML is a syntax extension for JavaScript that allows developers to write HTML-like code directly into JavaScript files. As you can see in this example, a JSX file allows JavaScript code to be directly embedded within the HTML content, unlike HTML applications. Another key difference between the two lies in JSX's compulsion to properly close all self-closing tags, like the image tag, the break tag, which is also a requirement in XHTML, but not in your regular HTML. Now let's increase the difficulty a little bit by moving on to our next question. Explain the difference between functional and class components. In a very straightforward way, class components were used before hooks. You can think of them as traditional, large and complicated machines. On the other side, functional components came into use majorly after hooks, making them the modern, easier to use choice in React. The class components were extended from the React.components and included the render method, which returned JSX. State changes inside the components are managed using this.state and updated with this.setState. Functional components, being used more frequently after the introduction of React hooks, use hooks like useState and useEffect to handle state and lifecycle events. Another difference between the two is that functional components used to be stateless, but after the introduction of hooks, they were able to manage states. If you bring this point up, the interviewer is very likely to bring up this next question. What is the difference between a stateless and a stateful component in React? Stateless components do not manage or store their data. They simply receive data via prompts and display it. They are best used when you don't need to handle any logic and just want your content to be displayed on the user interface. Stateful components, on the other hand, can manage their own state and can update their existing state based on user interaction or other events. This implies that they can handle complicated logics and produce the required output as well. With the introduction of React hooks, you can choose to keep functional components to be either stateful or stateless. We talked about prompts in this question, so let's look into that further with our next question. What are props in React and how are they used? Props or properties are a way to pass data from a parent component to a child component in React. The child components cannot modify these values because they are read-only. So instead, these values are used to trigger certain actions in the child components. You must have understood at this point that both props and state are used to control and manipulate how components behave and render. So it becomes crucial to understand the differences between them, which brings us to our next question. What is the difference between state and props in React? State is a mutable object that stores dynamic data, meaning it stores data that changes over time due to other factors such as user interaction, network requests, or other events, such as the count variable here, which increments or decrements its value based on user interaction. Props, as mentioned earlier, is an immutable object, meaning the data cannot be modified. Another notable difference is that state is private and is fully controlled by the component it belongs to. Props, on the other hand, is controlled only by the parent component and cannot be changed by the children. Moving on to our next question, what are controlled and uncontrolled components? Control components are used when you require control over the data being entered into a form, such as in the case of form validation, where you need to fetch the username and password to validate their authenticity. Uncontrolled components, on the other hand, are used when you do not need to dynamically inspect the user inputs, such as a user subscribing to your newsletter or a user uploading a file. In these cases, React does not need to directly react to the inputs because the data is being sent to the server for evaluation. Another important difference is that control components are accessed through the state attributes, which makes it easier to change. However, since uncontrolled components are managed through a ref, it becomes harder to access the values. That's all you need to know about controlled and uncontrolled components. Now let's move on to our next question. What is the purpose of the key attribute in React lists? Say if in this list containing apples, bananas and orange, I were to update only one of the fruit names, say orange, should the whole list be re-rendered? No, because it will be a waste of time since the other two elements never changed. In our case, React understood which element to re-render based on the key associated with that element. Key attributes, as the name suggests, is primarily used to identify each item uniquely when the list re-renders, enabling React to track and update individual items in the list without having to re-render the entire list. Moving on to our last question of this module, what are fragments in React and why are they used? Fragments in React are a way to group together multiple elements without adding an extra node to the DOM. Like this h1 and p tags that are grouped together with React fragments without adding an extra containers around them. In short, fragments are used when you want to avoid unnecessary wrapper elements like this div tag. And with that, we reach the end of this module. Now let's start with our advanced module with the first question we have, or the 11th question that we have, which is, what is the virtual DOM and how does React use it to improve performance? Now, what exactly is a virtual DOM? A virtual DOM is a lightweight copy or a lightweight in-memory representation of the actual DOM. Meaning, when you are running a React component, there are two DOMs. One is the original DOM and one is the virtual DOM. But why would we need a virtual DOM? Let me show you why. Look at this web page. Here, we have a simple click me button. Upon clicking on the click me button, this span element which encloses this particular number will change. That is, the number of times you click, it will keep on increasing. 1, 2, 3, 5, and it will keep on going. But just tell me about one thing. If you look at both of these web pages, there's only one single thing that is changing, and that is this particular element or this particular number which is inside the span element. So do we need to render every single component all over again? Do we need to really render this button, then this paragraph, and then this whole web page when only one particular span element is getting changed? No, because it will waste a lot of time. Now, although this web page is very small, it's quite a small web page, so you might not need to do a lot of work, a lot of heavy lifting here. But if this web page was a gigantic, like I had a lot of elements, a lot of styling and everything, and then only one single span element is changing, if React has to render the whole web page all over again, it will waste a significant amount of my time. You don't need to do all of that. And this is where virtual DOM comes to your rescue. What virtual DOM does is, whatever code you're writing, it checks through or it scrolls through your whole code to see what has changed. So this is your DOM hierarchy, and if you see, consider this is your h1 element, paragraph, and these are the list elements. So if you see in both of these codes, let's say we only change the paragraph element. So we don't need to re-render the h1 and the list elements because we didn't touch them. We only changed a little bit of code in the paragraph element. So only this particular change needs to be reflected in the actual DOM. And that is what virtual DOM does. Only the changes that are made in the code are made to reflect in the original DOM, and the rest of the components like our h1 and the list elements are not made to render all over again. Moving on to our next question. What are React lifecycle methods and when are they used? Let's look at the technical definition first. React lifecycle methods are special functions that provide granular level control to developers to hook into specific points in a component's lifecycle. The reason why we need lifecycle methods is so that you can attach certain events to a component's lifecycle. That is, when the component is first initialized, it needs to do this, and when it is when it is about to end, you need to do this, wrap up all of this, close these timers, and do this and do that when the component is about to be closed off. So to attach certain events to a component's lifecycle is why you need the lifecycle methods. Now, there are three main phases in the lifecycle methods. That's the mounting phase, the updating phase, and the unmounting phase. Now, these further have a lot of points under them, and while we'll look into them one by one, like this constructor, get derived state from proms, render, and component did mount. But when we're looking into these, I'll try to take an example, a hypothetical example, or maybe a real life example, so that you have a better understanding of what I'm trying to say. So constructor initializes the state and it binds methods. Say, let's take an example of a video game. So when you're starting to play that game, the initial state and everything is set. Yeah, like the player score is set, the player ID and everything is set. It's initialized, right? If you're a new player, every single thing starts from 0. So that is the constructor, the initial state. Next, you have get derived state from prompts. Now, what if you are an existing player? You used to play before as well. You just logged out from your computer yesterday. Now you're woken up, you started your computer and you're ready to play. So the stats must be fetched from somewhere. And that is this get derived state from prompts. When you have to fetch the data, some pre-existing data, and load this pre-existing data to the current value. That is update state based on prompts before entering. Next, you have render. Whatever changes happened, your database will try to fetch, or the game will try to fetch the data from the database. So if there is any data, then that is rendered and shown on the dashboard of the game. But if there is no data, if the user is completely new and there is no database existing for the user already, then there's no need to fetch the data. So the original dashboard only you can show to the user. Next, component did mount. This is just making sure that everything is working perfectly and the game was able to fetch everything and was able to display everything. Perform side effects such as API calls. Next, you have the updating phase. Now, there are a lot of functions in updating phase, such as your get derived state from prompts, should component update, render, get snapshot before update, and component did update. Again, get derived state from prompts. Your player is playing the game currently, right? So at some point, the player is able to gain some points, or they lost some points. So based on that, you're collecting these points, much like your virtual DOM. You're collecting these points that the player's score right now is 10. Now it became 20. So the new update is there. It's existing in the virtual DOM. Next, should component update. Now we decide the second score that we have, that is 20. 10 is not equals to 20, right? So the next score that we have is different from the original score, which means it needs to be updated. So in the should component update state, React checks whether they need to update the already pre-existing score or not. Render is after updating, it renders the whole screen and shows the next updated value on the screen. Get snapshot before update is before updating the screen, the dashboard with the original values, they need to make sure that the previous value is saved, right? The previous value, say I had a score of 10. So that score with 10 should be saved somewhere. And that is getting a snapshot before the update happens and before my score becomes 20, getting a snapshot of that. Then component did update is again making sure that everything was set and all right. Lastly, we have the unmounting state, which consists of only one function, that is component will unmount. So when the component is unmounting, there are certain things you need to make sure of, clean up the resources and event listeners and subscriptions. So whatever the player's session that was happening right now, every single thing, the connection to the database must be cut off, and the score should be kept to 0 back again because the game is shutting down anyways. So all of these things comes under component will unmount. And now moving on to our next question. Explain the useState and useEffect hooks with examples. Now, useState is basically used to store the fetch data and their loading states. useState, you can think of useState as a container in which you store a particular value. So say if you have a count variable. So every single time I'm increasing the value of count, it's stored inside this useState variable, and every single time I'm increasing it, the previous value is fetched from this useStates container. useEffect, on the other hand, is used to perform side effects, like when you're making an API call. So what happens in the background, that is all controlled by useEffects. It is used to fetch the data when the component mounts. So such as if you're setting up a clock, or maybe if there's a pop-up which is supposed to happen after a certain period of time. All of these actions are important, like a timer going on in the background, maybe a clock that is going on your web page in the corner. It is important, but it should not mess around with the main part of your web page. Some function needs to make sure that this clock is continuously ticking in the background, and at the same time, the important parts of the web page are also loading. That is where useEffect comes in. Let me show you an example so that you have a better understanding. I'll just create a file called as components. Okay. So inside this, for useState, let's just create a counter. And we need useState as well. Here, const count and set count. We're going to initialize with the value 0. We don't need this. We need two functions here, which will be increment, which will increase the value of count plus 1, and we'll have a function called as decrement, which will reduce the value of count as 1. Now, let's have a paragraph tag here which will display the current count, which will show the count variable. Next, we need two buttons. This should increment the value. On click, we're going to call increment. Similarly, we need one for decrement as well. So I believe our counter function is set. Let us call it here in the app function. Never mind. Okay. Counter. Now let's start our application. npm start. Alright. I haven't added this styling, that's why it looks a bit like this. So don't mind that. Now if we click on the increment function, you can see how the value is getting incremented. If we click on decrement, and we haven't set any limits, so it will keep on going as much as I want it to. And that is how useState works. Now let me just quickly show you how useEffect works as well. So for useEffect, in the components, let's just create a timer application. Oh, okay, we need useState anyways. For useEffect, you need useState as well. So useEffect and useState. We don't need this. And we need seconds and set seconds, which will have the useState value of 0. Now this is the timer. It will just keep on happening in the background. We need to call useEffect here. useEffect we're calling, and it will keep on incrementing this counter on its own. We need a set. Let's put it inside a variable. I'll call it interval only. set interval, and now I'm going to change the value of set seconds. Whatever the previous value will be of seconds, it will be incremented by 1. And this will keep on happening every 1 second. Okay. And then we need to clear it out as well. Clear the interval. And okay. So inside of this, let's just add an H3, which will display the timer seconds. All right. Now let's try importing the timer here as well. All right. Let's look how our code looks. All right, the timer is already keep on happening in the background. So that is useEffect. So I can keep on interacting with my main application here, and this timer will also keep on happening in the background. That's how useEffect is working. Let me just stop this, else my I'll just remove them from here. Okay, else the timer will just keep on going on forever. So let's move on to our next question, which is our 14th question. Another interesting concept in React. What do you understand by props drilling? Props drilling, it's like if you have multiple children in a same parent element. There's a parent, there's a child, there's a grandchild, there's a grandchild. Now there's a possibility that one of the props that you're getting in the parent element, now although the child element and the grandchild element do not want to use it, but the grand or the great grandchild wants to use that particular prop. So it needs to pass through all of these components as well. It needs to pass through the parent, and it needs to pass through the child, grandchild, and then it will reach the great grandchild. So even though the child and the grandchild really don't need to use a component, they will still need to pass it through them so that the great grandchild gets it. And that's where that becomes a problem if there are like too many nested elements. What if it had even like a great grandchild, and it would just keep on going, and then that would just become hectic at one point, and you just lose track of where the prompt was actually supposed to go and where it actually went. Or in technical terms, props drilling is when data has to be passed through many layers of components. Let me just show you an example, because that's the easiest way to understand. So we need multiple components now. We need a parent. We need a child. We also need a grandchild. All right, we'll start with the parent, which is in here. Parent is the only component which is present in the app.js. Now consider the situation where parent is the only component that is present in app.js. So whatever prompt we're getting from here, from the parent component, must be passed down to the grandchild component. Say in the app, I'm going to import useState, and in here I am setting the user. Oh, I don't need to set the user, I'll just create the user. Name, what do you call him? John. Age, John is 30 years old. Okay, so I'm passing this particular user's data to the parent component. Here I'll give it as a prop, user. Now keep in mind that right now from parent, child and grandchild, only parent has the access to user. Now grandchild wants access to user as well, but grandchild can only be accessed through the child element. So in the parent element, what I'm going to do, I'm going to call the child, and the user I am getting from here, I'll have to pass it through here. Okay. Now this child component really doesn't need to use the user, but still, because grandchild is linked to the child element, it will need to pass the user prompt through the child element. So here I'm going to call grandchild and pass the value of user through child element, and finally it will reach the grandchild element where it will show the name of user, or maybe just say hello name. It was name, yeah. Let me just remove these two. I believe I'm not showing the grandchild component. Maybe I can just, okay. Now you can see that how even though the parent and child components, none of them used this user data, still it was getting passed through the parent and the child and then the grandchild, and only then the grandchild could use it. Now imagine if there were like maybe 4 or 5 even more components. So it will be like A, B, C, D, E, F, G, and then G will get the component. Are you looking at how deeper the nesting just keeps on going and how hectic it can get? So that is why props drilling is one of the cons of React. And there is a wonderful way you can solve it. Let me show you what that wonderful way is. That will bring us to our next question. What is the context API and how is it used for state management? Now, context API is a way to solve the problem of this props drilling. How? What context API does is, instead of the props having to go through all of these intermediary components, context API can create a global variable, or it can provide a global space where these variables will automatically get stored in, so that whenever other variables or any other child components wants to get this variable, they don't have to go and ask their parent where is the variable, and then the parent asks their parent. It doesn't have to be that way. You can just directly go to this global space and retrieve the component or retrieve the variable, whatever it is looking for. Or in technical terms, the context API in React is a feature that allows you to manage and share state or data globally across a component tree without needing to pass prompts manually at every single level. Let me show you the code for this. So for creating a context API, you need to create a user context folder, inside of which we're going to store the user context file. Okay. I'm just going to call this as context, because inside of this I'm going to create user context.js. Alright, same here as well. The difference is I'm going to call create context, and I also need a useState to store the state of the variables. So let me just export it here itself. User context is create context. I don't need this line. All right. Here, I'm gonna call this user provider, and this will have children. Just bear with me, you'll understand what I'm trying to do when we reach the end of this, but in the middle it might look a bit hectic and stressful, but just bear with me. Now this is the function that we're going to export. Inside of this, let's create user and set user. We need the same thing. Right. When we are returning, will not be a div. It will be a user context.provider. The value will be user. And inside of this, we'll let the children. And I believe that is everything we need. All right. So now if my grandchild component, which was accessing the particular this hello.name, let me just remove everything from here. for the parent as well. We don't need to do any of this or this. Okay, so now in the grandchild component, in the app.js, or maybe let's just have the child component. I can show you how they're like still calling onto the function, but they're not passing the values and still it's getting displayed. Okay, so in the grandchild component, instead of this, I can just import user context from this, and alongside of this I'll need to call use context. Keep in mind this is use context. And alright, so now I can create a user here. I can retrieve the value of user from here, which is use context, user context, and I can just have hello user.name. Okay, let me just remove this. Alright, let's see how that turned out to be. Alright, we've done something wrong. Child is calling grandchild, parent is calling child, app is calling. Let me just remove that. Alright, so we need to wrap this up in user provider. Let's just wrap the parent class in the user provider. Alright, now let's look at the code. So yeah, it is showing the data over here. And now we're able to directly access. Alright. Let me just keep it as welcome. Okay. So now we're able to directly access the value of John, which was only accessible to the parent component. We're able to access that component in the grandchild component as well. And that is how Context API works. So moving on to our next question. What are higher order components? Give an example. In technical terms, a higher order component is a function that takes a component as an input and returns a new component with additional functionality or modified behavior. This we even have higher order functions in other programming languages. I believe we have it in Java as well, where you take another function as an input and then you can return the function as an input as well. So that's called as a higher order function. Similarly here also, say if you are having a website in which in every some of the pages are only accessible to like say premium users. So how do you make sure that every single web page which is accessible to premium user is authenticated? To authenticate the premium users itself, you need another function, right? Or you need another component which is dedicated to authenticate the users. Now how do you apply it in every single page? You cannot just go to every single page and manually type in the code. That will be like a lot of work. That is where higher order components come in, because you can have one single higher order component which takes another component as an input. You can keep it separately, and in every single web page you can just integrate it with the other web pages, which can reduce your time significantly. So let me show you how this is going to work. I'll guide you through every single step, so just bear with me because this is also going to be a little bit hard. So what we're going to do, so we're going to create a hello world component, and we're going to create another function, a higher order function, which is we're going to call it as a higher order function. And this higher order function will take this hello world as the input. The hello world will be coming from the hello world component. It will be a whole file like our this parent.js. Hello world will be a hello world.js file. From that we'll take the hello world, and this enhanced component will take hello world as its input, and we'll just add maybe what like hi hello world or some other prompt to this particular hello world, and we'll return this. We'll enhance it or we'll just modify it. Let me show you what I'm trying to say. So first we're going to create an HOC higher order component.js. All right. Now we'll have to create a wrapped component. Now this is the input. the whatever input we're taking, that will be inside this wrapped component. Okay, so we don't need multiple lines. We're just going to return one function which will be enhancing or modifying the component. I'm just going to go with enhance component. I'm going to take the props and we're going to log into the console whatever the new modification is happening. Backticks, rendering, wrapped component dot name, whatever name it is, with props, or just simplify it, modifying with new props. Okay, and we're just gonna return this wrapped component plus whatever prompts that we made. All right, and we're just gonna export that. Now we're gonna create a hello world function or a hello world component, and inside of this, say we're taking a prompt, say a name, and we're just gonna return hello, not world. Whatever name is coming here, we're going to return it right here. Let me add an exclamation mark. Now what we're going to do inside the same function is I'm going to add that component. I'm going to add the HOC component inside of this component. So let me do that. I'm just going to call it enhanced hello world. I'm not typing it out. Now I'm going to call HOC and I'm going to pass hello world as the prompt inside of HOC. Let me close that. You did not import. I'll have to import HOC. All right. And instead of returning hello world, I'm going to return enhanced hello world. So, all right. So now let's just create our HOC component. So what we're going to do is that we're going to create an HOC component. We're just going to create it and then we're just going to keep it aside. And in the meantime, we'll create our another component. Say we're going to call it, say, greet component. And in that greet component, we'll pass in the prompts. And we're going to pass this greet component or this greet function into the HOC component. Let me show you how that is done. So initially, we need our HOC component. And this is gonna return wrapped component. This will be the higher order function that will be, this will be the other component that will be taking. We're gonna need a function enhanced component which will take props and it's gonna log modified wrapped component with new props. All right, that's good to go, and we have to return wrapped component plus props when we are returning it. This is how the function is going to return. Now we need our greet function or component. All right. Initially, it's going to take a prompt called as name and it's going to just welcome it. Hello, the name. Now what we're going to do, we'll call our higher order component, which will be stored in this variable called as enhanced greet. We're going to call HOC and we'll pass greet in this HOC and we'll export it. Now in the app.js component, we need to remove that. In the app.js component, we'll call our enhanced greet and we'll pass in a name as say John. All right. We have done some error. This is HOC. All right. And if I were to go to my console, you can see the modifying this function with new prompts, which means a higher order function is able to take this function and modify it and return you the output. So that's all for this question. Let's move on to our next question, which is explain the concept of reconciliation in React. Now, reconciliation is like a process in React when it's like what happens in the background when a particular component is updated and how the virtual DOM and the original DOM is working together to display the content in the user interface. Let's look at them one by one. There are obviously different phases for this. The first part is the initial render. That is when a component is first rendered. When it's first rendered, React naturally creates a virtual DOM to check what has changed in your code, and whatever changes have been made, only those certain elements which you have changed in your code will be reflected in your original DOM. Only those components will be rendered. The other components will not be rendered as no change was made to those components. Next, you have state or props change. Now, when a state or a props change, React creates a new virtual DOM. Every single time a new virtual DOM is created, because it's a lightweight copy of the original DOM, so it doesn't take a lot of effort or it doesn't create a lot of performance optimization issues. So every single time you render the component, a new virtual DOM is created, which checks whatever changes have been made and updates accordingly. Next, you have diffing. Now, diffing is basically the comparing part is called as diffing, or maybe the difference between the both of them, the original DOM and the virtual DOM, that is called as diffing. Next, you have the updating the DOM part. Whatever changes are there in the virtual DOM because of the changes in the code that you made, only those things will be changed in the original DOM as well. That is called as updating the DOM. Next, you have committing phase. That is whatever changes were made, rolling them out and committing them to the original DOM is called as committing phase. Finally, React commits that changes to the actual DOM. Moving on to our next question. How do React portals work and when should they be used? React portal is a way to render a component's children into different parts of the DOM outside the parent component's hierarchy while maintaining the React code component structure. I'll tell you what this means. Now, React portal is basically when you need to create a particular component, like maybe a modal or something like a pop-up. You must have seen pop-ups when you're trying to use websites and suddenly there's a pop-up about some advertisement or something. That thing, that particular div element or that particular element, that is created using React portals. Let me show you how. That is called as a modal. Let me show you how that is created. So we need to create a modal component. It's going to have two prompts, which will be is open, which will make sure that it's visible, or if it's hidden, it will decide if it should be visible or it should be hidden, and then the children. Now, if the portal is not open, then we don't need to do anything. So just return null. However, if it is open, then we'll call React DOM. We need to import React. We're going to create a portal here, inside of which we're going to call a div. And we're going to show the children in here. Children is basically whatever the components will be having inside the modal. We'll need to style it a little. This is going to be a bit hard now. Inline styles are always hard, but top is say 50 pixel, left is say 50%, transform, translate 50%. Color, let's put it as white. Background color, let's put it as purple. What else do we need? Padding, 20 pixels. We might need, okay, let's not add box shadow. We'll have only this much. And it should be shown in document.body. All right. Okay, we have everything. Now let's try to import it in our app.js. Let's remove that. We need, oh my god, okay. And we need useState here. So in here is modal open and set is modal open to control their states. It will be a Boolean value, so let's start with the false. And we have an H1. Welcome to React portal. And we need to add two buttons here, which will be the open modal and the close modal. So when you click on open modal, we're going to set is open modal to true. And when you click on close modal, this will be close and it will become false. Let's see how that came out. So if I click on open modal, nothing's happening. We did something wrong. Let's see what we did wrong. We did not call modal. We were supposed to call modal. We'll set is open as is modal open. We'll just add this is a modal. And the close one should be inside of this. Now let's see. All right, create portal is not a function. Oh, okay, this is React DOM. Okay, this is the modal and we can close it. And that is basically how React portals work. So let's move on to our next question. How does React router handle navigation in a single page? Now, React in a single page application, React router is used to handle navigation between different user pages without the need to reload the entire page. Now, what router or this navigation does is that you don't have to go around and have different IP addresses for everything. Instead, everything happens inside a single page and you can navigate to different pages like your home page, about contact us page, all of these. Let me just quickly show you how to integrate it into your React.js application. Now, before you do this, make sure to install your React router DOM. So while that's happening in the background, let me just go to my app.js and I'm just going to remove everything. Okay. Now we need to import browser router from React router down. As we need multiple things now. We need router, we need route, we need routes, and we also need link. This is very important, so make sure that you pay attention. We need router, route, routes, and link. Okay, we got everything. Now we're gonna create a function as our home page. So let's create our h2 tags here. and this will be the home page. Similarly, we need to do this for about and contact as well. So this will be the about page, and this will be the contact page. All right. Now let's just set up routes to all of these. So inside of this, we need the router. Inside the router, we need the div. Inside of this, we need the navbar. Finally, we have the UL. In here, we'll add the link. And let me just close that. Okay. So this will be the link or the root directory, which will be the link to home. Next one will be to the About Us page. Another one will be to the Contact Us page. Okay. Contact, About. Now we need to set up the routes, which we will do outside the navbar. Routes. And in here, route, and we're just gonna have the root path as our home. It's a component with small c, and let's just close that. Another path we need about, which will show the about component. Lastly, we have the contact component, and that summarizes our routes. Let's start the app and let's see how it's coming out. Let me just close the previous React app. Okay. All right. Now, if I click on any of these, you can see how I'm taken to the about page, to the contact page, and the home page or the default root page. Moving on to our last question, which is, what is React strict mode and how does it help developers? If you must have heard about the Java strict mode, React strict mode is also similar to that. Let's look at the definition. React strict mode helps developers identify potential problems in an application by intentionally invoking certain warnings and behaviors in the application. So the React strict mode essentially acts as a safety net, just to make sure that all the safe coding practices, so that you practice all the safe coding practices, and that whatever warnings that you're getting in your code early on does not lead to an error later on in the code. And with that, we reach the end of this particular module as well. So thank you so much for watching.